So it's now 2:15 or 3:15 on European time. And welcome everyone, and welcome to this session dedicated to IoT for industry. My name is Marielle Campanella. I'm in charge of European projects at SCS Cluster, which is a digital cluster based in the southeast of France and specialized in ICT technologies. And within this session, we will have the opportunity to present you the main results of the IoT for industry project, and to give you more concrete examples of activities funded within IoT for industry as a European project for the deployment of IoT solutions in industrial environment. It will be also the time to award the best IoT for industry funded projects with a dedicated award ceremony in a few minutes that will be presented by my project colleagues. So let me tell you, first of all, a few words about IoT for industry. IoT for industry is a European collaborative project funded by the European Commission as part of the H2020 program. It is made by a consortium of 8 partners coordinated by SCS, and it started on the 1st of April 2018 and is going to finish by the end of this year. So we received an overall budget of 4.8 million euros, including 3.7 million euros directly dedicated to European SMEs in a dedicated funding scheme that I will explain you later on. So the IoT for Industry Consortium has been composed in a way to clearly represent the cross-sectorial value chain of smart industry and to be able to best support SMEs in their aim of developing new collaborations. So it is composed by 8 partners, including 3 ICT clusters with the DSP Valais in Belgium, Microtech Sud-Ouest in Germany, and Pôle SCS in France, 3 industrial clusters with MESAP in Italy, Pôle Mecatech in Belgium, and Montblanc Industrie in France, and 1 technology center, MTC, that you know, and in addition, 1 consulting company specialized in innovation support, GAC Group. In addition to these 8 partners, we were associated to a number of ambassador clusters for the promotion of the project toward their local ecosystems in their respective countries. So the general objective of IoT for industry is to enhance the productivity, the profitability, and the innovation capacities of European manufacturing SMEs by developing their access to IoT technologies as smarter means of production and by modernizing their processes and security. It also seeks to accelerate the access to the market to new products and services which are provided by technology SMEs by strengthening innovation and growth in Europe. So concretely, this is done by matching digitalization demands in the manufacturing sector with technological offers, thanks to cross-border and cross-sectoral collaboration between ICT and industrial actors. So to do so, IoT for industry relies on the principle of cascade funding. So for those who are not familiar with this process, cascade funding is a mechanism to distribute public funding in order to assist beneficiaries, so SMEs in our case, in the uptake or development of digital innovation. So this funding methods aims at simplifying the administrative procedures, creating a light SME-friendly application scheme in which EU-funded projects like IoT for industry can issue open calls for further funding coming from the European Commission. So these open calls are competitive, they have a European dimension, and they aim at supporting pilot demonstrations and experiments on a specific innovative technology. It is a funding scheme which is very much appreciated by SME because it is close to the market and it is agile, it is fast, and also it is accessible with a higher rate of success than other EU instruments and with light reporting. Additionally, we can mention also that it brings a real added value for SMEs, since in our case, it is managed by clusters that are daily working to mobilize and support companies all along the innovation process. So after a phase of training and matching, which has been and matchmaking, which has been done at the beginning of the project, IoT for Industry launched via this process of cascade funding 2 open calls in 2 years. So supporting different types of projects. So firstly, feasibility studies for companies having an idea of the project they would like to develop, but with needs for further analysis of some technical aspects or design studies and so on, corresponding to TRL, so technology readiness level between 4 to 5. The second type of projects were prototype projects for a company having already carried out a feasibility study and having the need to develop prototype and to spend more effort in testing, so corresponding to TRL 6. And then demonstration projects for companies having already developed and tested prototype and with the need to demonstrate its efficiency on a larger scale, corresponding to TRL 7, 8. So projects have been requested to gather at least one entity representing the IoT side, so then with the technology offer, and another entity representing the industry side, the demand side, which could be a machine or a tool manufacturer or a factory, for instance. And at least one of these entities shall be a European SMEs. So the funding scheme were different according to the type of projects. It was up to 25,000 euros for feasibility studies, 45,000 euros per SME for prototyping, and 65,000 euros per SME for demonstration and pilot, with project duration between 6 to 12 months. So concretely, the funding scheme, so that has been launched through these 2 open calls, focused on the application of IoT technologies in the manufacturing environment. So it financed small and market-oriented projects involving SMEs, so consisting of the integration and the use of IoT technologies, including big data, artificial intelligence, and digital security, into machines, into robots, manufacturing tools, industrial processes, into factory environments. So projects here were requested to have a strong international dimension involving entities at least from 2 different regions of Europe. And they were expected to be innovative, namely to go beyond the state of the art in terms of technologies used and the use cases addressed. And a clear application was expected, oriented toward the industry, which involved a final customer or final end user coming from the industry. So finally, after these 2 open calls, we received in total 149 proposals. And after an evaluation process made by external experts based on predefined criteria related to excellence, impact, and implementation of the proposed applications, in total, 40 projects were funded for a total amount of 3.7 million euros addressed directly to 40 to 84 SMEs. So 95% of these projects are close to the market, namely prototype or demonstrator, and 95% of them are transnational. It's important to underline also that large companies have also been fully involved in the funded projects, and the role of clusters here was important to help in connecting promising SMEs with the large companies for the deployment of their project and their experiments. So before going more concretely into the technical part of this project, let's give a look more closely to the application sectors of these 40 funded projects. As you can see on this graphic, there is a broad range application sectors with a good map of involved regions. Automotive is strongly represented, as you can see here. Part-wise, because automotive is highly represented in IoT for Industry cluster countries, with Italy and Germany, for instance. We can see also that highly advanced sectors and high-tech industries are well represented, since it is indeed easier to sell IoT technologies to automotive than to traditional manufacturing sectors, such as food or textile industry. Let's keep in mind as well that highly represented sectors are typical sectors with high profit margins, and they are typically early adopters of such technologies. So concerning the countries of the partners of these 40 projects, we can see that there is a broad distribution because cluster cooperation was efficient. 32 project partners came also from non-consortium countries. So countries which are not represented by the 8 partners of IoT for Industry. And Eastern Europe is also represented with 9 organizations. This graph shows the distribution of all project partners, but the graph specifically for funded SME looks actually similar. This third slide is about the location of the end users, which is very often the place where the funded projects have been tested and deployed, where the technologies have been actually carried out. We can see that there is a high number of end users in non-consortium member states. Italy and Spain are quite overrepresented. This is very likely due to the traditional strong focus on manufacturing of these countries. And technology transfer to end users in Eastern Europe could probably be increased by funding for end users as well. So after this first overview of what IoT industry is about, let's go more deeply into these funded projects. As mentioned earlier, IoT for Industry has a European project, is going to close by the end of this year. So we have decided now to put the emphasis on these concrete projects that have run thanks to IoT for Industry. And we have decided to run a contest among those projects in order to award some of them. So now I'm going to give the floor to Thibaut van Roeden, project partner of IoT for Industry, who is going to tell you more about our contest and this award. And then you will see some very concrete examples of this type of technologies.
Well, good afternoon, everyone, and thank you very much, Marielle, for the introduction. My name is Thibaut van Roeden. I'm working at Polymegatech, cluster in mechanical engineering based in Wallonia, Belgium. I have the honor to guide you through the award ceremony of this IoT for Industry video contest. And let me tell you a few words about why we decided to organize a contest between a video in the first place. We had over more than 40 projects. Marielle told about it, and the idea that it was that this contest was a way to give them additional support first of all, but it was also an incentive to push people not to forget to communicate about the excellence of their solution. The rules were quite simple. Each participant had to realize a video of maximum 120 seconds. The video had to demonstrate the innovativeness of the project and also the link with the IoT for Industry thematic and its scope, and also the sustainability. The reward was quite straightforward. It's a prize, 5,000 euros for the winner, 3,000 euros for the project ending second place, and 2,000 euros for the project ending on the third place. Now, before jumping through the 3 finalists, we received over 14 different videos that were submitted. You can find all these videos on simply on YouTube. Our partners from MTSC, our German partners, did put them online. You just simply have to type in project IoT for Industry in the search and you find them. Watch out, it's project with a K. So let's move on now to the finalists of this contest. And the 3 finalists are in alphabetical order: Equality, Matak IoT, and Sense4Com. So we're now going to go through the 3 videos, and shortly after, we're going to discover the final ranking. Let's go for the videos.
The Equality project is composed of 3 companies, Verhert, Lisaplast, and Hopoo. The goal of the Equality project is the creation of an agile system to predict the non-safe zones for pregnant and nursing women in the production plants based on ICT's technologies. The Equality project makes use of IoT devices for real-time air quality monitoring called SmartSpot, provided by Hopoo. These devices include volatile organic compounds. Lisanplast, as a production plant, has been the testing environment. Equality has installed smart spots in different zones of the plant to collect the data. These data are analyzed through a software platform based on Grafana, an open-source technology that allows to analyze all the data to obtain conclusions and export them to other tools and to create reports. Verhert has been the company which has worked with the data, building diffusion physics model with a set of parameters optimized using big data analysis methods. To improve the user experience of the foreman and make easy the detection of dangerous areas for the pregnant and nursing woman, Verhert has developed an app called Emission Predict Equality. It allows the prediction of harmful areas related to the VOC emissions, CO and particles matter concentration in a heat map visualization of the production plant depending on the kind of extruded material. The exploitation of the results is linked to the commercial activity of each of the 3 companies that make up the consortium. Lisanplast is exploiting the results of its work-life balance programs for nursing and pregnant women. Lisanplast has been able to deliver to each work the EPIS adapted for its work position, and it allows to adapt the work zones to reduce the impact of harmful zones for all the workers too. Verhert has generated know-how that open new opportunities to develop similar tools for other production processes as a new service. Hopoo has increased its annual turnover by 15%, setting a precedent in sales and projects with industrial customers, which helps diversification.
Carbon dioxide emissions. This is the main cause of global warming. Each industry needs to chip in. Aerospace is no different. Fuel reduction is a top priority. One opportunity is to make the airplanes lighter. How do we do it? Using a mixture of glass fibers and resin, we create a composite material which is light, strong and durable, an ideal material for airplanes. But is this material safe? How can we test it? This is where the Sense4Com project comes in. The idea is to use optical fibers. If we embedded them inside the composite materials, we can monitor the quality of the composite during production and when the composite is part of the plane. A complete solution for quality control and safety, from cradle to grave. What are we developing? We activate the optical fiber with UV light. The light is creating a pattern inside the fiber, and this pattern is sensitive to temperature, pressure and strain. Embedded in the composite, this allows complete control of the production. But that's not all. We need to read out the response of the fiber sensors. We need high-speed readout unit to detect possible cracks. Sense4Com is developing a unique solution, low-cost, miniaturized and extremely fast detection unit, able to detect the response of 8 sensors in one fiber, all in the same time. The next time you are boarding an airplane, take a moment to look around, and perhaps you will see some composite panels lighting up, giving you a safe feeling. World, here we come!
Okay, so without any further notice, let's jump now to the final ranking between the projects, and I will start with the third place, the bronze medal if you like. Now the bronze, or the third place, goes to Matek IoT. Matek IoT, congratulations, that's a French project led by Savoie Transmission. It's an application turn milling. The video is it's an excellent video, very much oriented toward the customer. Great effort, congratulations guys for this video. Now let's move on now to the second place. And the second place is going to, it's going to Sense4Com. So that's a Walloon-led project. Congratulations to BSense, which is the leader of this project, BSense. Congratulations to Christophe and his team. Congratulations to Somnai, your Dutch partners in that regard. That's a very interesting project, an application of Bragg fiber in the aerospace at Sonaca. So great job, guys. You have the second place of this contest. And of course, the winner, that's the last project of the list. That's another Belgian-led project. It's Equality. It's led by Verhart with an implementation in a Spanish factory. It's also a very interesting project, interesting application, which is showing how you can tackle a societal issue at work with technology. So that's it. Congratulations to the three projects. Congratulations to the winner, Equality. I'm not going to go into more details about those projects because my colleague Alessia is going to take over and to go in a dialogue with these projects and to tell you all about them. But before I leave her the floor, I just want to tell you that there's a second session today about IoT for industry in about a bit more than an hour, where you're gonna have the opportunity to hear more about IT for Industry project. Other project leaders are going to give a testimonial about what they did, and there's also a presentation of EU funding opportunities with a representative from the Commission. That's it from my side. Congratulations once again to the three projects. And Alessia, the floor is yours. Alessia, I leave you the floor. Thank you very much for your attention.
Thank you, Thibault. Hello, everybody, and welcome in the IoT for Industry digital experience. My name is Alessia Mendoni of MESOP Innovation Cluster, that is an Italian cluster located in Turin and focused on smart product and smart manufacturing. As anticipated by Thibault, we will go through the IoT for Industry video contest winners to better understand how those solutions have been implemented into manufacturing. We basically realized 2 interviews, and what you will see is a very short, very condensed version, and then we will see a demo realized by Sense4Com. I give immediately the floor to the first project called Matek IoT and presented by Pierre Aguaro of Savoie Transmission.
Thank you, Alessia. In a nutshell, the project is about a predictive maintenance device. It's a small sensor that we can put on a machine, whatever the machine is, to check the behavior of the machine itself. This sensor is measuring temperature, hygrometry, ATM pressure, as well as 3-axis magnetic field, vibration, and shock. This is reported into a dashboard, which is accessible for everybody with a password, etc., which is really protected. The user gets periodic report, and based on threshold, he can receive alert. If we have a deviation by 20%, I'm sending you an email saying you should go to visit your motors or your machine because something happening over there. With this dashboard, we have a little bit some artificial intelligence with a 7 days prediction. So we have a tendency of the 7 coming days in order to see if you have chance to reach one of the thresholds. The other thing is, which is done post measurement, is a correlation analysis. So the added value, as I said, is planned instead of breakdown, event identification and corrective action instead of premature obsolescence. Then you can use as well the sensor in order to check the condition of use. Because some of time you have certain condition of use. For CMP, for instance, it is really important that temperature and hygrometry are respected. Last but not least, you can plan your maintenance based on the curves. You can imagine when you will have a problem, and you can manage easily your maintenance with no emergency. Just to show you a little bit of how it works, and that's a machine on the right. You have a atmospheric plasma machinery, which treat some pieces for the industry, so watches industry. And one of the difficulty we had is you have other machine running and working around. So the first video show you that the noise around, because you have machine here and elsewhere that are doing some work. So I don't know if you see on the right, but you have a signal.
Yes, I see something.
Yeah? Okay, perhaps it's too small. And
yeah,
there's a machine that works. It's really a tiny vibration, but the signal is really different. So you have on the right the signal, the original signal, and on the left the signal that we have seen together. So here the sensor detects that the machine is running. That's time to do a measurement.
Yeah, thank you very much for your time, and thank you for sharing with us your interesting solution. See you, bye-bye.
Thank you, Alicia, bye-bye.
Welcome back in the IoT for Industry digital experience. It's a big pleasure for me to present a quality project. It is the result of a Spanish-Belgian cooperation, and in particular between three companies that are Verheert, Hoopoe, Ubiquitous, and Lezenplast. And the project focused on gas monitoring in critical environments. I give immediately the floor to Emmanuel, Jan, and Iris to better understand what quality is.
Our goal has been to try to monitor in a factory environment, more specific in an extrusion company, the quality of the air, to be able to adapt the schedule from pregnant women or women who were just giving birth and still giving breastfeeding. Maybe I have to specify that there is European legislations of how many concentrations of every volatile organic component. But for pregnant women, the concentrations are even lower. So we have to be even more careful. We introduced in the Smart Spot a new sensor, and this sensor is measuring VOX of volatile organic components. With all this data that we could measure in the production area, then my colleague Jan was bundling all the data.
Well, I would like to specify that what is interesting is that through the big data approach, it was possible to make this prediction based on inference to infer the pollutant production of each of these machines without having to stop and individually test them. We developed an implicit model for the diffusion problem, which was very interesting to do, and it's also very interesting because it's very generally applicable to other problems. Any diffusion problem, whether it is in air, in liquids, whether it's a diffusion problem in an industrial setting, in a factory.
Next question is the market opportunities you see, and if you are planning to go on market.
In general, we can add it because equality opened for us for open new opportunities, and now we continue working with the sensors in the factory because we are connecting directly the data in real time via blockchain connection with Alastra institutions, and we are working with the official body of standardization, AENOR, from Spain, for generate new parameters and new politics based on standards who transmit directly the IoT device in factories via blockchain for assure the data in all the aspects and helping to follow up the different emission and the control the different parameters who is the machines working in the industry in base of different regulation. It depends of the material, and in general the context and the companies who is know this action are totally interesting in these new steps.
Thank you for your time. Okay,
Alessia. Thank you very much for your time.
Thank you. Bye-bye. Ciao.
Bye. Thank you for your time. Ciao.
Last but not least, it's my pleasure to present Sense4Com. The project is a result of a Belgian-Dutch cooperation between BSense, Sonaca, and Sony Solutions. So I give the floor virtually to Christophe Koster of BSense. He realized the demo. Thanks to, we will discover in a very practical way how Sense4Com works.
The goal of the Sense4Com project is to equip composite materials with optical fibers. To this aim, the BSense company in Belgium teams up with the Somni company in the Netherlands to provide a solution fully integrated in carbon-reinforced composite materials. Our sensors are distributed and embedded during the manufacturing process, and they can afterwards be used during the lifetime of the product to predict the possible appearance of cracks or failures. In the fabrication process, we use a standard telecommunication grade optical fibers and this laser technique to ride fiber grating inside. So the very first step we need to take is to put the optical fiber in the system so that it can be irradiated by the laser. Our optical fiber sensors are then embedded within the carbon fiber plies at the Sonaca company, and the manufacturing process of the composite materials is made in an autoclave. We have also designed and built an original smart interrogator. You can see an example here in the printed circuit board that allows sending light into the optical fiber and collect the signal for visualization here on a spectrum analyzer. You see the spectra of two gratings that are embedded in the composite material, and if I apply some pressure on the material, you can see that we can follow exactly the strain that has been applied. The added value of our project is the ability to follow in real time the strain profile in composite materials, and this using a smart and cost-effective interrogator. The next steps of the project are clearly to integrate further the smart interrogator and add the communication aspect to get a smart object, and certainly to bring it to the market for aerospace industries. From the fiber to the interrogator, the Sense4Com project brings a full solution to the composite material industries.
So thank you everyone for listening. Just to finish, I remind you that an IoT for Industry dedicated session will be held at 4:30 British time, 5:30 European time, during which a product advisor from the European Commission will give insights on European funding opportunities concretely. This presentation will be followed by pitches from the IoT for Industry funded projects made by SMEs, which will present their concrete IoT solutions for manufacturing industries. So stay tuned and see you in a little more than 1 hour.